What are the use cases of EMQX? What's the difference between the enterprise and open source editions of EMQX? These are common questions people have about EMQX. Today, in this video, we will dedicate a few minutes to addressing these concerns. As a messaging server, EMQX holds the potential to be utilized across a multitude of application scenarios. Connected automobiles, industrial Internet of Things, energy, wastewater treatment, instant messaging, and smart homes represent diverse industries that leverage EMQX. This is attributed to their common requirement for device accessibility and message transmission. Consider a situation in connected vehicles where a user wishes to unlock their car remotely. This exemplifies a typical application where it is paramount to safeguard the user's command from being received by other vehicles, guarantee a swift return of operation results from the networked vehicle, and potentially manage millions of vehicle terminal connections to our messaging platform. These requirements of reliable message delivery, low latency message transmission, and management of a vast number of device connections are fundamental competencies of EMQX. In the real world, we need to write the recipient's address on the package, so the courier company can locate the corresponding recipient. In EMQX, each message is assigned a topic indicating the intended destination of the message. EMQX identifies the subscribers to this topic and forwards the message accordingly. In contrast to real-world package delivery, which may take days, the span from message dispatch to receipt in EMQX is typically clocked in milliseconds. Through this topic-based publish-subscribe model, we can cater to one-to-one communication by sending messages to specific subscribers, one-to-many communication by dispatching messages to multiple subscribers simultaneously, and many-to-one communication by receiving messages from numerous publishers. These three communication models can cater to any message transmission scenario. In EMQX, messages can flow from one terminal device to another, or directly to a backend data analysis service. This is made possible by the data integration functionality of the EMQX Enterprise Edition. Messages can be forwarded to event stream platforms like Kafka for real-time data processing, or stored in time series, databases like InfluxDB, or NoSQL databases like Redis for regular offline analysis post-storage. Additionally, EMQX features a robust rule engine that allows for extracting, filtering, and transforming messages before they are forwarded or stored, enabling data pre-processing without the need for backend application services to participate. In addition to the rule engine and data integration, EMQX offers many extremely practical features. It supports all standard versions of MQTT and common IoT standard protocols such as COAP and LWM2M. To improve communication performance in weak networks, EMQX first proposed and implemented MQTT over QUIC, significantly enhancing message delivery and transmission speed in weak networks. EMQX also provides comprehensive communication security protection formed by SSL, authentication, and authorization mechanisms. With EMQX's abundant log and monitoring abilities, visual configuration, and the feature of immediate effect after configuration modification without the need for a restart, we can accomplish operation and maintenance tasks with much greater ease. Certainly, this is but a small part of the rich features of EMQX. Currently, EMQX comes in 3 editions: EMQX, EMQX Enterprise, and EMQX Cloud. For those newly introduced to EMQX, the differences between these editions may initially seem perplexing, but let me elucidate. EMQX is our open source edition, which is entirely free and open source. The open source and enterprise editions are built on the same kernel, thus exhibiting identical core capabilities such as protocol access, cluster expansion, and rule engine. The primary distinctions between the enterprise and the open source editions lie in the capabilities of message persistence and data integration. The enterprise edition supports persisting messages to disk, avoiding message loss due to service restarts. It also provides over 40 data integration capabilities for quick integration with other business systems to expedite business delivery. The main difference between EMQX Enterprise and Cloud is that the former requires user deployment and operation, while the latter offers a fully managed service and exclusive features such as custom functions and shadow services. Additionally, EMQX Cloud, having passed SOC 2 certification and other compliance certifications, is suited for companies with overseas needs, obviating the need for re-auditing for compliance due to self-built environments. Of course, these additions have more differences than just these. You can visit our official documentation for a detailed feature comparison if you're interested. In addition to its array of features, EMQX also boasts stellar performance. With millions of message throughput and millisecond-level message latency, EMQX is the preferred choice for many companies. Our exhaustive optimization upgrade to the cluster architecture in version 5.0 further enhances the cluster expansion capacity and device access capacity of EMQX. As a result, we can now effortlessly build an EMQX cluster comprising more than 20 nodes, and such a single cluster can support concurrent connections of 100 million terminal devices. A typical deployment architecture for EMQX involves at least 2 EMQX nodes forming a cluster to ensure high availability. A load balancer like HA proxy uniformly distributes MQTT connections to different nodes, ensuring an equitable load across all nodes. EMQX only provides access to MQTT and common IoT protocols. For complex industrial protocols such as Modbus, CIP, and OPC-UA, we introduce Neuron EX, an industrial edge gateway. It can convert myriad industrial protocols into MQTT and relay the data stream to EMQX. It also incorporates a built-in stream data engine that enables data filtering and processing at the edge, reducing unnecessary data transfer. Finally, we can deploy an appropriate backend to process the data further. If there is a need for monitoring, we can integrate with Prometheus and Grafana to achieve visual monitoring management of EMQX. Since open sourcing on GitHub in 2013, we have garnered nearly 13,000 stars, with total downloads exceeding 40 million and still rapidly growing. Over 20,000 enterprise users from over 50 countries and regions worldwide have chosen EMQX. We believe that EMQX will always be your best choice for MQTT platform.